In 7.1, we're going to review rational expressions. And one of the most important things to realize is that the word rational means fractions. So if you have a rational number, that's just a number, just two integers, one in the denominator and one in the numerator. But a rational expression, like the ones on example 1 and 2, have a polynomial in the numerator and the denominator. So for example 1 and 2, what it wants us to do is evaluate the rational expression. So it wants us to plug in the number everywhere that there is a variable. So notice that I have put a set of parentheses everywhere that the variable is located. And now I'm just going to plug in the number 3 that it's want me to plug in, and I'm going to simplify. That numerator becomes 5, and then in the denominator 3 squared is 9, plus 6, plus 5. So that gives us 5 over 20. On number 2, I'm going to plug in a -4 everywhere that we see that variable of w. So I went ahead and rewrote the expression and put parentheses everywhere that there was a w. And now I'm going to go in and put a -4 there. And so I get -6 minus 7 -3 0. And in the top, so -6 times -7, that's a positive 42, all divided by 3 times 0, which is 0, which 42 over 0 is undefined. You cannot divide by 0. On example 3, we have a word problem. It has multiple parts. Let's just read through this. Jan's Cake Company has a fixed monthly cost of $3,500 plus a variable cost of $8 per cake. The average cost per cake, C, in dollars, is given by this equation, this function, where X represents the number of cakes produced. So find the average cost per cake if Jan's company produces 500 cakes. So all we have to do is plug the number in where there is a variable in that equation. So plug in the number 500 there. So plus 8 times 500, all divided by 500. So once you multiply 8 and 500, you get 4,000. Add 3,500 to that, you get 7,500. Divided by 500, and you get 15. And so that means it's $15 for 500 cakes. So let's see what happens when we produce 750 cakes. So I'll put this in my calculator, and I get 12.6, and the 6 is repeating. So that's an average cost of around $12.67 per cake. So see, when they produced more cakes, the price went down. And when you plug in 1,000, the price goes down to $11.50. So let's look at something else now that we've learned how to evaluate a rational expression. Let's talk about restricted values. Right now, if you typed in your calculator 1 divided by 0, you would get an error message, or 2 divided by 0. Anything divided by 0, you can't divide by 0. In fact, I have a little thing I use to remember that. No, you cannot divide by 0, but it's okay to have it in the numerator. Anyway, On 4 through 7, we're going to look and see what makes that denominator equal 0. And basically what you want to do is just take the denominator and set it equal to 0 and solve it. So right here you're going to add 2 to both sides. So g equals 2 is what makes that denominator equal 0. Like right now, if I plug 2 in, 7 divided by 2 minus 2, 2 minus 2 is 0. And you can't divide by 0. Okay. Right here, again, you take your denominator and you set it equal to 0. Now this is where module 5 comes in really handy, because we're going to have to factor this and set the factors equal to 0. Factors of -8 that add to give me -2 would be f minus 4 and f plus 2. If I set those both equal to 0, I get that the restricted values are 4 or -2. Here, setting the denominator equal to 0, x squared plus 16 equals 0. Think about module 5 really quickly. You have a formula for binomials: difference of squares, difference of cube, and sum of cubes. This is not a difference, this is a sum, right? But this isn't cubes, this is a square. Well, there's no formula for sum of squares. So basically, you can't solve this, so there are no restricted values. Okay, and on this one, set your denominator equal to 0. You're done. A equals 0 is your restricted value. Number 8 wants us to construct a rational expression that would be undefined. So basically, if your denominator had, let's see, undefined for x equals -3. Well, if you had -3 plus 3, that would be 0. And then if you had one minus 1, that would be 0. And you can just put anything you want on the top. That's a wonky looking 5. On number 9 and 10, it wants us to do two things. Part A wants us to identify the restricted values, so that's what we did in the exercises right before this. And then Part B wants us to simplify the expression to its lowest terms. Okay, so let's look at number 9 first. And the restricted values, I just say 9x minus 18 equals 0. So 9x equals 18. So x equals 2 is the restricted values. Now, so that's part A. Part B, to simplify this expression to its lowest terms, you want to factor everything. So the numerator, you can pull out a GCF of 6, and you're left with x minus 2. And in the bottom, if we pull out a 9, we're left with x minus 2 as well. Also, we could go even further and think, well, 6 isn't prime. 6 is 2 times 3. And 9 is 3 times 3. And so now to simplify, we just cancel what repeats in the top and the bottom. 1, 3 repeats, and the factor of x minus 2 repeats, to leave us with an answer of 2/3. For part A on number 10, we're going to set that denominator equal to 0. That's a difference of squares. Square root of 9x squared is 3x. Square root of 16 is 4. So the restricted values would be negative 4/3 and 4/3 if you set those equal to 0. So now for part B, to simplify the expression, we want to completely factor, if at all possible. So the numerator, I can pull out a GCF of 5 and be left with 3x minus 4. That bottom factors into a difference of squares. And so our repeating factors on the top and the bottom cancel to leave us with 5 divided by 3x plus 4. So number 11, we're simplifying to the lowest terms. And as part of the final answer, I'm going to go ahead and tell you a couple of ways to think about this. 30 divided by 36. 6 goes into both of them, into 35 times, and into 36 6 times. The fraction 30 over 36 simplifies into 5 over 6. So you can think about it that way. Okay, or you know how I said to factor everything completely out? The 30, you can say, well, 30 is 3 times 10, and 10 is 2 times 5, and 36 is 6 times 6, but 6 is 2 times 3. Okay, so we can write it out like that. And then now a cubed divided by a to the 5th, you keep the base and subtract the exponents. So it's negative 2, a to the negative 2 power, but if you put it in the bottom, it stays positive. Basically, the bigger power was in the bottom, so that's where a is going to stay at. Now with b, the bigger power is in the top, so b is going to stay in the top, and 4 minus 1 is 3. So this is actually our final answer, but I'm going to show you the way where we factor it all out. I've already done the prime factorization of the numbers. Let's do the variables. A cubed is a times a times a. B to the 4th is b times b times b times b. A to the 5th is a times a times a times a times a. And we have a b. So let's cross out things that repeat. A 3, a 2. Now there's another 2 and another 3, but only 1 2 and 1 3 repeated. An A, another A, another A, and a B. So let's write back down everything that was left. There is a 5 and a B, B, and B in the numerator, and a 2, a 3, and an A and an A. So that is 5b squared over, 5b cubed over 6a squared. So two different ways to think about it. On number 12, when we're simplifying this, it looks like, so as far as as far as 6 over 10, 6 over 10 simplifies into 3/5. You could think of that as 2 times 3 and 2 times 5, where the 2's cancel to get 3/5. If you have a c to the first and a c cubed, so 1c right here and 3 factors of c right here, the 1c will cancel with one of these to leave you with 2 c's, so c squared. And this factor of c plus 2 cancels completely with that factor of c plus 2. And this factor of c minus 1 cancels with one of those factors of c minus 1 to leave us with c minus 1. And I just rewrote it to where it looked a little nicer. Now on number 13, I'm going to need to factor it, or at least try to factor it a little bit. Let's see, 12 and 20 have a 4 in common. They also have an x to the first power in common. If I divide out a 4x, that would give me 3x minus 5. In the bottom, we have a GCF of 8 and x and y, the lowest power of each variable. So we're going to divide everything by 8, x and y. And 24 divided by 8 is 3. 3x and 40xy divided by 8xy is just 5. Okay, so now 8 over 4 simplifies into 1/2. Okay. The x right here completely cancels. The y stays. And now, whenever you're looking at 3x minus 5 and 3x plus 5, you're wanting to cancel them, but you can't. The 3x's don't cancel, the 5's don't cancel because they're married, right? The 3x is married to the -5 by the minus sign. The 3x here is married to the +5 by the minus sign. And while they visually look very similar, they're not exactly the same. So I have to go back and copy those back down. For our final answer. On number 14, that top has a GCF of 7. If you factor it out, you're left with x plus 2. The bottom, factors that multiply to give us -12 and add to give us +4. Or if they're multiplying to give us a negative, they're different signs, and if they're adding to give us a negative, the larger number is negative. 6 and 2. Okay, so now the x plus 2's cancel, and we're left with 7 over x minus 6. When we go to look at number 15 to try to simplify, we want to try to see if anything factors in that numerator, and it doesn't, and nothing factors in that denominator either. I do realize it's a binomial, but they don't factor, and therefore they cannot simplify. Nothing repeats and cancels out. On number 16, I'm going to look to factor that numerator and the denominator. So the numerator, we're going to use that AC method on this trinomial. We're looking for the two things that multiply to give us -12. So if you're multiplying to get a negative, your signs are different. And the two things that also would add to give us +1, and we're getting that +1 from right there. So since you're adding to get a positive, your larger number will be positive. So you could use 3 and 4 and make your 4 positive and your 3 negative. So what we would do is rewrite that trinomial on the top as 2x squared plus 4x minus 3x minus 6. And I'm going to group the front and the back. Now, I will just mention again, the order in which I wrote the 4 and the 3 doesn't matter. I could have written 2x squared minus 3x plus 4x. The order doesn't matter as long as the signs are correct. Anyway, as far as factoring by grouping goes, that front binomial has a GCF of 2x. Once you factor that out, you're left with x plus 2. The back binomial has a leading coefficient that is negative. And we can also pull out a 3. So if you pull out a -3, you're left with x plus 2. You're left with x plus 2. If you pull out x plus 2 from both sides, you're then left with 2x minus 3. So that's the numerator. The denominator, I'll do in a different color. I'm going to group the front and the back. I can take out an x squared and be left with a minus b. And in the back, I can take out a negative because your leading coefficient's negative, and take out a 4. And you would be left with a minus b. So if you took out a minus b, you would be left with x squared minus 4. And x squared minus 4 is the difference of squares. So I'm going to rewrite the rational expression in its factored form. Okay, when I do that, I notice that we have a factor of x plus 2 that repeats in the top and the bottom. So we're left with 2x minus 3 divided by a minus b times x minus 2. And just realize, I mean, I do realize visually, yeah, there's a 2 on the top and the bottom visually. But the 2 in the top, first of all, it's 2x. That is married to a 3 through subtraction. And this 2 down here is married to this x through subtraction. So that's a factor of x minus 2. That's a factor of 2x minus 3. They would have to be the same exact factor in order for those to cancel. 17 has 3 parts to it, but it's wanting us to identify whether these pairs are opposites. What I'm going to do, I'm going to write the variable portion in the front and just the number in the back. So a minus 3, it's already set up like that. Okay, but the one right here, I'm going to put the negative a in the front, and it's a positive 3. So do you notice that as far as the a goes, they're opposite signs, and the 3, they're opposite signs. So this pair is opposites. For this one, I'm going to put the w, the variable in the front, and the number in the back. So this one here would move the w to the front and the 6 in the back. They're exactly the same, so they're not opposites. And this one, the variables in the front, the numbers in the back. Let me move the x to the front here and the 5 to the back. And this one's the same as well. so they are not opposites. So the exercise in 17 was useful for simplifying something like this, where it looks right now like they would just completely cancel out and your answer would be 1. Well, in the state that these binomials are in, they're not exactly the same. The one in the top has a positive 5 and a positive y. The one in the bottom has a negative 5 and a negative y. But what I could do is factor out a negative 1 from the bottom. Let's just do it in the bottom, since that negative 5 is a leading coefficient that is negative. So the top I'm going to leave the same. The bottom, factor out a negative 1, and you're going to be left with 5 plus y. So now those are the same, and I'm left with 1 over negative 1, which is equal to negative 1. Now on number 19, factoring out a negative isn't going to work. Your b is the same sign. They're both positive in the top and in the bottom, but the 6 is different signs. So, I mean, I could factor out a negative 1 from one of them. Let's see what happens. That would be negative b minus 6 all over b minus 6. My b's and my 6's look really similar. Anyway, the negative b minus 6 doesn't cancel with the b minus 6. They both have a negative 6, yes, but one's a negative b and one's a positive b. So this one does not simplify. So in the top, we have a difference of squares. Square root of 64 is 8. Square root of g squared is g. Okay, and in the bottom, factors of a negative 24. So you're multiplying to get a negative 24, so your signs are going to be different. They had to give us a negative 5, so your larger number will be negative. G minus 8 and g plus 3. So notice I'm not for sure right now if anything cancels between this g minus 8 and the 8 plus g and the 8 minus g. Let me rearrange them to where the variable is in front, just to see if it's any clearer. So I have a g plus 8. This could be considered negative g plus 8 in the back. In the bottom, that still is g minus 8 and g plus 3. Let me again explain what I did here. I didn't really do anything in the numerator except put the g, swap the places with the g and the 8. Put the positive g in the front and the positive 8 in the back, and put the negative g in the front and the positive 8 in the back, just so that I could compare it to the g minus 8 that is in the bottom. And even though I did that, it's still not the same. But let's try to factor out a negative 1 from this one right here, because that's super similar. So I'm going to leave the g plus 8, and then I'm going to factor out a negative 1 from the negative g plus 8. And if you factor out a negative 1 from negative g plus 8, you get g minus 8, and then the g minus 8 in the bottom, and the g plus 3. So now the g minus 8 cancels to leave us with negative g plus 8 divided by g plus 3. And notice I put that negative out in front. So we're going to start by trying to factor. In the top, you can pull out a 4. You're left with x minus 2. And in the bottom, you can pull out a 6. And you're left with 2 minus x. That looks super similar. Let me try to factor out a -1 from, let's just say, the top. So there's the 4 still. I'll factor out a -1. That would leave me with -x plus 2 all over 6 times 2 minus x. So now these cancel because it's a -x and a -x and a +2 and a +2. And also the 4 over 6 would simplify into 2/3, but we have the -1, so -2/3 is our answer. Now number 22 that is on the back of, on the next page, we don't cover that in this class, so we are going to skip over that and go to 7.2.